So there are different ways to write a quadratic function. One way, we call it the general form, is f of x equals ax squared plus bx plus c. Now, you've seen that form, a similar form, back when you had the quadratic formula. So remember when you had ax squared plus bx plus c equals 0? And you used that to derive the quadratic formula. Okay, so now it's just written, though, as a function. Okay, this is called the general form. It's a great form for certain things. Let's leave it at that. The standard form is written this way. F of x equals a times x minus h squared plus k. This is more when we were working with transformations. And it's generally called the standard form. So you have the general form and the standard form. They also call it in the book the vertex form, which is fine. But most textbooks I've seen call it the standard form. Either way. So this tells us certain things. It tells us about transformations, right? So we know if a is negative, it's going to reflect, about the x-axis. And a will also make it either a stretch or compression. So it could show a reflection about x-axis. And it could show a stretch or a compression, vertical stretch or compression. So A does a lot. H tells us a vertical shift. Horizontal shift. H for horizontal. Okay. It tells us a horizontal shift. And K tells us the vertical shift. Okay, so that's, how that works. So if you had a parabola, the basic one, and you're shifting it over H and up or down K, then that's where your vertex is going to be. Okay? So when you have it in this standard form, one of the nice things, let me scroll back a little bit. One of the nice things about the standard form is you can see where the vertex is right off. The vertex is at the point H, K. Oops, that's a K. So if you played around with the transformations, that idea a little bit, hopefully that would make some sense to you. Okay. There's also what we call the vertex formula. This comes from the general form, okay? So you can't really tell what the vertex is just by looking at the general form. But if you apply the quadratic formula, you can get it into a form where you would know what the vertex was. Okay, but I'm just going to they show you that in the book a little bit, but I'm just going to tell you what the vertex formula is. So if it's not in standard form and you need to find the vertex, but it's in general form, you can use this. And it says H is equal to the opposite of B over 2A. And then K is equal to F of whatever you got for that value. Okay, so the vertex formula, sometimes I'll write it this way. The vertex of a quadratic function is going to be negative b over 2a, the opposite of b over 2a, and then you have to evaluate the function at whatever you got for h. Okay, so this is generally how we write the vertex formula. I'm sure it's in your book. They kind of wrote it out in pieces, I think, for h and k, but either way. Okay.